rather quickly in the sake of time, but basically I'm gonna explain while this is running. So all I'm doing here is basically accessing the Pangeo intake catalog that is stored, basically gives you access to all of the CMIP6 datasets stored in Google Cloud Storage. I'm then going to select a couple of these models just to keep the time down that we need to process them. I'm only going to look at the historical runs and the strongly forced SSP585 scenario. And then I'm also going to subset a couple of model members because some of these models actually do have quite a lot of members. So this takes a little bit of time to load, but you can see that we're loading almost 400 data sets here. And we're taking about under a minute, so that's way faster than downloading the data set. What I'm doing then is post-processing, which is also part of the CMIP6 pre-processing package. And all we're doing here is sort of cutting the time to a common value, matching the metrics, which is a really handy function. Sort of the metrics we loaded is the horizontal cell area, which is not the same in all of the models, or not the same distributed across space. And so we need to actually weigh the sea surface temperature with the area. And then I'm just going to concatenate the members of the models if available, so that ends up as an additional dimension in the X-array data set. You'll be able to see that here in a second once these steps are done. And then we can actually go to the meat of the computation. And really what I want to highlight, the real computation is a one-liner here. So we have a loop over all of these combined data sets, and we've done all of the work with CMIP6 pre-processing to set that data set up to really enable this absolutely simple computation. What we're doing here is we're taking the sea surface temperature, we're then using X-arrays syntax to weigh that with the horizontal cell area, where we need to fill missing values with 0, and then take a mean over the X and Y dimensions, so over the horizontal space, and that's it. All else I'm doing here is pretty much the extra stuff. So I'm basically, let me just throw this on while I explain. I'm basically coarsening this to just like, this is just a visual thing, so we get annual averages a little less noisy, and then I'm just plotting. So most of this stuff here really is sort of configuring the plotting with X-array and assigning colors to the different models. But like the actual computation is happening just in this step, and I really like how easy that actually becomes. We're gonna wait here a little bit. This is sort of the meat of the computation. Should take about a minute or so. We're timing this as well. You can see on the right here, little nice task graphs. You can see that there's like all the workers communicating with each other. You can see progress bars of all the tasks, and down here you can see all of the tasks sort of being processed in parallel for each of the models. Should be done fairly soon. All right, here we are. So this took about a minute, and what you're seeing here is basically the average sea surface temperature for a bunch of the models in different colors. Where available, we have the members sort of as transparent lines in the back, and the member average, or the ensemble average, however you want to call it, as a thick line. You can see there's sort of big differences between the different models, and it's up to you to like identify what is causing that. But yeah, just to sort of drill that message home, we just went through 40 plus gigabytes of data in a few minutes. And if you're assuming that you have a fast internet connection and want to download this kind of data with like 20 megabytes per second, you would spend at least 30 minutes to just downloading the data. Wouldn't have even written any code or processed anything, just so to demonstrate how much quicker this approach actually is. And you also only need a web browser.